I think we need a judicator.
I thought we were both right. I thought we agreed.
Technically, but I still want to just double
You want a
check.
second opinion?
I do.
All right. Well,
So-
we just happen to have a mathematician in the field here. He lived with the deer.
Sir, Professor
Ah.
Alfie. Shut up, Pew.
Ah.
I had a lesson, yes, let's just ignore him. I had a lesson from Miriam, and she informed me that actually if you have circumference divided by the diameter, that you get pi. And she knows you and you know her and I trust you and her. So I don't understand why his is correct also.
Well, he made it plausible. Could still be different, but actually you're both right. Now one wonders, this very different things, the circumference and an area, both are related to pi. That's an extraordinary coincidence. And one shouldn't trust coincidences. Usually there's some reason. Just things don't happen out of nothing, and there's a reason for both to be equal. And I'm now going to show you why. So we now try to figure out why the circumference pi and the area pi are the same. For that we have to find some way to determine the area of this circle. What we do know is what the area of a rectangle is. If we have rectangles with the sides, say A and B, the area is A times B. Now, we don't have a rectangle here, but if we cut it, we can make similar to a rectangle. So we start by cutting it into 4 pieces, and we will rearrange So now these 4 pieces still have the same area of the whole circle as before. The point is now we arrange it differently.
Okay.
And then this way. And this isn't a rectangle, but it comes a little bit closer to it than our original circle shape.
Clever, isn't he?
That's impressive.
Clever. All right.
So let's have a look.
All right.
Start with that one.
So this doesn't really look like a good rectangle yet.
Rectangular rectangle from this, I have to admit.
Well, so there's one thing we could do. Just cut it again into more. So, and always arrange it with the tips up and tips down. So cut again, and maybe it looks a little bit more like a rectangle.
Cut like that, yeah?
Yes,
Okay.
all of them.
Right.
You arrange it tip down, tip up, tip down, tip up.
Let's start gently.
Tips down and tips up, sir.
Right, so one tip up,
One tip up,
so one tip down.
one tip down.
Okay.
Okay.
So, wonderful work you did. This looks a little bit more like a rectangle, isn't it?
In a caterpillarish sort of a fashion, yeah.
Yes. Of course, to improve on that, we again cut it half. Will you do that?
Yeah.
Yeah, okay.
This is where we suggest all of our viewers go and put the kettle on. So I assume tips up, tips down.
Yes, you're right. You're smart.
Only because somebody pre-told me.
All right.
All I'm
All
going to
knowledge is
suggest.
pre-taught, right? Yeah.
Now this looks more like a rectangle. Just look what the sides are of this rectangle. The side here, because it was cut that way, it was a sector of the circle. This is a radius. Now you see the other side.
Oh yeah, look, that's our radius line. Very
Yes.
good. Yeah.
The other side, just see it's the black line here, continuing on the upper side, and the black line was our circumference. Just a short explanation. You have now a rectangle. So, and this was the very thick line that was our circumference, which has been cut in half. So this side is circumference halved. This side here was the radius, and the radius, as we recall, is a half of the diameter. So now there's the point. What did you teach us? The circumference has something to do with pi. So pi was, as we said earlier, the ratio of circumference and diameter. Now, this means that the circumference may be obtained, I abbreviate as pi times diameter.
Okay.
Now we figured that in here. Circumference was pi times diameter
You're right.
divided by 2 multiplied.
By the radius.
Yes. Now, half of a diameter is a radius.
Right.
So the area is pi times radius times radius. So it's actually pi times
Radius.
the radius squared,
Right.
and that's what we said. It's 3 and a bit times the square we did over the radius.
Told ya. But you were right too.
So we're both right, and it's not a coincidence, as can be shown by this rectangle.
Brilliant. Thank you.
You're welcome.